Christine, and we're going to learn about the chi-square test. And to answer the questions, why should we use it? What does it mean? How to calculate it using a spreadsheet? And how to interpret its value. So, let's start!
Let me begin to answer the question, why would we use it? Let's look into this example. Let's assume that you are a college student in a large university, and your classmate makes the claim that the population of the students in a university is 50% male and 50% female. But you are not convinced on his claim. To convince you, your classmate proposed an experiment and said, let's randomly choose 30 students and let's see the distribution of the genders. Let's say that you had 16 females and 14 males. You may think that maybe the claim is right, but what if it is 18 females and 12 males? Or 21 females and 9 males? That's a bit doubtful, right? When you ask these questions to different people, you will get different levels of comfortability when it comes to the claim that the population of the students in the university is 50% male and 50% female. And when you ask them at what point they stick to that claim, the often answer is, I'm not sure. And there lies the problem. We can't rely on the gut feeling or intuition when it comes to making conclusions about claims and evidence. We need a more robust analytical tool to help us out. And that is why we need the chi-square test. Now, what is a chi-square test? A chi-square test evaluates the inherent variability by comparing data that was collected to the data that the researchers predict in a given specific claim, and with that, the null hypothesis enters. Now, what is a null hypothesis? A null hypothesis is a claim statement that can lead to a predicted experimental outcome. Let's go back to our example experiment. In our example experiment, our null hypothesis would be the gender population of the university is 50% male and 50% female. And with that, it will allow us to clear prediction of what we would expect when we choose a sample of 30 students at random. Now, let us say that the actual data in the example experiment is 18 females and 12 males. How does this stack up to the claim of 50-50 university gender population? To find that out, we need to calculate the chi-square value, and to do that, we need this equation. As you can see in the equation, it states that the chi-squared value is the sum of the observed data, which is the data collected, minus the expected data, which is the data being predicted based on the null hypothesis, squared, then divided by the expected values. On a practical standpoint, it is easier to use a spreadsheet like Microsoft Excel to perform this calculation. And how are we gonna do that? Take a look on the columns. We have column B for the category. For male, we have cell B4, and for female, we have cell B5. Column C for the hypothesized proportion, which is our null hypothesis of 50% male and 50% female, or we can just have 0.5. Column D for the observed data, and column E for the expected data. To start, let's determine our observed data. We have an observed data of 12 male and 18 female. Then, let's add the collected data. Put an equal sign, then type sum, open parentheses, click the cell B4, which is our observed data for male, colon, then click the cell B5, which is our observed data for female, close parentheses, then press enter. We can just simply put 30 here, but it is good if we have a formula for the sum of our observed data so that if the collected data will change, the sum will also be automatically changed. For our expected data, we can easily put 15 in this area, but to make it sure that our expected data is correct and right, we will also create a formula. Click equal sign, then C4, which is the hypothesized proportion, multiply by D6, which is the sum of our observed data, then click enter. Just do the same for the next row. Since we already have our observed and expected data, we can now run the calculation for our chi-square test sample experiment. Click equal sign, open parenthesis, then click D4, which is our observed data for male, minus E4, which is our expected data, close parenthesis, squared, then divided by E4. Just drag the cell to copy the equation in the next row. Add the column G4 and G5 to get the sum of the chi-square. Click equal sign, then type sum, open parenthesis, click G4, colon, G5, close parenthesis, then enter. Now let me show you another way to get the test statistic. Excel has a function called chi-square test. This function will calculate the p-value. First, type the equal sign. Then type CHISQ.TEST. Open parenthesis. Click the observed data, comma. Click the expected data, close parenthesis, then press enter. We just got a p-value of 0.273321678. Now, let's calculate the test statistic. We can use chi-square inv.rt. Type equal sign, then CHISQ.inv.rt. Then, click the cell for the p-value, which is B10, comma, degrees of freedom, then press enter. We have a test statistic of 1.2, which is the same value we got before when we calculate the chi-square using the formula. We have a sum of chi-squared value of 1.2, but what does this number mean? In order to interpret the chi-square value, we need to consult this table. When we already have the chi-square value, we need to know some important information to read the table. First is the row of the table we need to look at, and it depends on the degrees of freedom that we have in our example experiment. How are we gonna do that? To do that, we need to identify the number of categories we had in our example experiment. The formula on finding the degrees of freedom is quite simple. Degrees of freedom is equals to n, stands for number of categories or row, minus 1. In our example experiment, we only have two categories, namely male and female. Therefore, the degree of freedom in this test is 1. Let's go back to our table. We now know that in this test, we need to focus on row 1, for those are the chi-square values of 1 degree of freedom. But, which column representing the different values probability are we to look at? It has agreed upon of all the scientists that the significance level of probability is 0.05 or 5%. In this case, a chi-square value of 3.84. This probability basically means that if scientists are to perform such experiments many times, they are expected to see this chi-squared value 5% at a time if the null hypothesis is true. This frequency may be a little bit low, but it is high enough for the scientists to agree that the differences between what we observed and what you expected were not large enough to reject the null hypothesis. Then, what does this mean when we interpret our chi-square test? Looking at our example experiment, the chi-squared value of 1.2 is less than 3.84. and thus corresponds to area of the table associated to the probability value that is higher than 5%. Therefore, any chi-squared value that is lower than the one associated with the probability of 5% does not allow us to reject the null hypothesis. Note that the terminology is not that we can accept the null hypothesis. We just can't reject it as a possibility. So in our example experiment, we had 12 males and 18 females as our evidence, with a 1.2 chi-squared value. Therefore, we cannot reject the null hypothesis that the population of the students in the university is 50% male and 50% female. If, however, we had a collected data of 24 females and 6 males, we have a calculated chi-square data of 10.8, which is greater than the significant value of 3.84 and corresponds to an area of the table associates with a probability value that is less than 5%. And by that, we can reject the null hypothesis that the university probably has more females than male. In summary, to interpret the findings of your test, find the chi-squared value associated with a probability of 0.05 and the correct degrees of freedom for your experiment. If the calculated chi-square value is less than or equal to the value of 0.05 probability, you cannot reject the null hypothesis. But if the calculated chi-square value is greater than 0.05 probability, then you can reject the null hypothesis.
And that ends our discussion about chi-squared test. I hope that you have learned something in this video. Don't forget to like and subscribe this channel.